Hey guys, Mr. Piercy here, and what we're going to be taking a look at in this video is how to find the area of a regular polygon. Now, irregular polygons can generally be broken up into more basic shapes like parallelograms or squares or triangles and such, but regular polygons have a particular formula for how they are worked, just like triangle has a particular area formula and and parallelograms have a particular area formula. Polygons also have a an area formula associated with them. Now, the center of a polygon is basically the same thing as the center of a circle. It's wherever the radii of the polygon would extend from, and meaning that if I inscribe a polygon, a regular polygon inside of a circle, the radius of the polygon and the radius of the circle will be the same thing, as you can see in the diagram on the left. The epitome of the polygon is a segment that goes from the center of the circle to one of the sides at a right angle. So it's going to be it's like the altitude of an isosceles triangle. It will bisect the interior angle, the central angle, and it will also bisect the sides, the side that it intersects. So for instance, in the diagram on the left, segment AC is an epitome. It will bisect angle BAD, and it will also bisect angle BD. And the central angle of a regular polygon is pretty much the same thing as it is for the central angle of a circle. It's the it's the angle that's formed in between two radii of a polygon. So now we're going to be taking a look at just how we use some of those parts of the figures of the regular polygon, so that way we can know how to identify them and know what they do in a figure, so that way we're not going to be thrown off by them, or we know how to find certain things if we need them in a problem. So here we have a regular polygon, a regular hexagon in this case, inscribed inside of a circle G. We want to find the measurement of the central angle. So going back to what we did way back when we were talking about just angles of polygons in general, the measurement of a central angle is going to be found by 360 divided by the number of sides. So for example A, it's telling us that angle EGF is a central angle. So EGF is going to be equal to 360 divided by the number of sides, which in this case is 6. And so here, the 360 divided by 6, I don't know why my cursor is hanging out over the 360 divided by 6, but that gives me a central angle of 60 degrees. So now we move on to part B. GH, we want to find the measurement of angle EGH, but we can't get it directly. But GH is the apothem, which makes it the altitude of an isosceles triangle. Therefore, it will bisect the measurement of the central angle. So here, the measurement of angle EGF is 30 degrees, half of the central angle. So part C, find the measurement of angle HEG. Well, HEG, that's going to play off of the property of angles of a triangle, adding up to be 180 degrees. So we know that one is 60 and one is 90, so the other one has to be, one is 30 degrees, so the other one has to be 60 degrees. Now here I've added a little note. We can conclude that triangle EGF is equilateral, and that triangles EGH and FGH are 36 and 90 special right triangles. Now, because the hexagons, regular hexagons, do contain equilateral and 36 and 90 special right triangles, it is a favorite favorite regular polygon to ask questions about, because it will allow you to use trigonometry, Pythagorean theorem, and rules of special right triangles if we need to when working them out. So regular hexagon is a very popular question because of the equilateral and the special right triangles that it contains. So how do we get this formula? The area of the area of a regular polygon is 1/2 times a times p, where the lowercase a is the apothem of the polygon. The capital P represents the perimeter of the polygon. N would be the number of sides, and S would be the length of the side. So here, these two equations are essentially the same thing because P is the number of sides multiplied by the length of the side. So either way that you want to write the equation is perfectly fine. 1/2 AP or 1/2 the apothem times the number of sides times the length of the side. Now, where did these formulas come from? So again, part of the thing that I want to make sure that you guys understand is not just the fact that I'm the math teacher and I say this is the formula, so use it just because. Well, where did it come from? Here we're going to figure out the area of a regular polygon simply by using area of a triangle. So the area of a regular polygon is equal to however many regular triangle or how many triangles is contained between the radii. So in this case, so if we were looking at the one above, we could find the area of one triangle and multiply it by 6, and it will give me the area of the hexagon. So the area of a regular polygon is going to be found by saying n times the area of a triangle, where n is the number of sides. So the base and the height in this case would be the length of the side of the polygon, and the height would be of the triangle would be the apothem of the polygon. So that's where we get 1/2 times SA inside of the parentheses. Now, the parentheses aren't really necessary. We're just simply showing you that we're taking the number of sides and multiplying it by how many triangles that there are. So if I put it inside, if I take the n and I put it inside the parentheses and just get rid of the parentheses completely, I can say 1/2 times the apothem times the number of sides times the length of the side, or perimeter is n times s, so I can rewrite that as 1/2 AP, where I replace p with the n times the s. That's where the formula for area of a regular polygon comes from. Now we're going to actually try using it. Now here we're finding the area of a regular octagon where the sides are 3 centimeters long. It has a radius of about 3.92 centimeters. Find the area of the coaster. Well, as we saw in the last slide, we have to know some things. We have to know, well, what's the apothem? We have to know the length of the sides, so that way we can get the perimeter. Well, in this case, we know the length of the sides, so we can find the perimeter that way. There's 8 sides, and so 8 sides at 3 centimeters each gives us a perimeter of 24 centimeters. Now we need the apothem. The apothem is not given to us directly. Now, I want you guys to kind of pay attention to the triangle that's right here. That triangle is found by taking 2 radii. So like RQ, that is a radius. That's 3.92. So is RP. RP is a radius of 3.92. Ultimately, every regular polygon that we evaluate, that we're trying to find the area of, ultimately it's really going to just be based off of one of the right triangles that's contained between the 2 radii. So that's really what we're going to be looking at. So looking at the right triangle there, we can find the apothem using the Pythagorean theorem. The radius is 3.92. One side of the right triangle, the other leg of the triangle is 1.5. So we can use that information to find the apothem. So, and over here on the left, that's the note that I'm adding here is, oh, hello, I have an email. Sorry about that. Go away, email. Finding the area of a triangle is essentially just comes from looking at one of the right triangles that's formed between the apothem, half of a side of the polygon, and the radius of the polygon. So we can use the Pythagorean theorem to find here the apothem, in this case is about 3.622 centimeters. Now that I know the apothem and I know the perimeter, I can substitute those values and say that the area is about 43.5 square centimeters. Alright, so at this point, guys, go ahead and pause the video and attempt to answer the 2 questions that you see on the screen. When you're done, go ahead and hit play to come back and listen to the explanation and look at your answers compared to mine. Okay, so hopefully we have some good answers here. You've taken the time to work the problems out correctly, or at least attempted to work out the problems. So in the first one in the diagram, FGHJ is a square inscribed with the circle. So find the measurements of the angles. So we want to find what are the measurements of those angles. Well, in this case here, I'm going to find the measurement of angle FKJ by saying 360 divided by 4. So angle FKJ is 90. Well, the two other angles, KJF and KFJ, those have to be supplementary. They are complementary. They have to have a sum of 90. And because KF and KJ are both radii of the same circle, or of the same square in this case, the triangle that we're working with is isosceles, so the base angles are the same. That's why I'm saying KJF is equal to KFJ. So both of those added together have to be 90, so that means KJF has to equal 45 degrees. Moving on to problem number 2, find the area to the nearest square inch of the regular pentagon. Again, they're giving us the uh, length of a side and they're giving us the radius. So here, what we look at first, just like in the last example, anytime I'm evaluating the area of a regular polygon, it's really going to be coming from a right triangle contained within inside of it between the apothem, the radius, and half of one side. So here I'm finding the apothem, again, kind of using just the Pythagorean theorem. The hypotenuse is going to be the radius of the polygon. So 6.8 squared minus 4 squared, take the square root of that, and I get about 5.5 inches. Substitute the number of sides times the length of each side, and we get an area of just under 110 centimeters squared. So I didn't write my answer to the nearest square inch, but should have been to the about 110 square centimeters. 0.982 rounded to 3 decimal places for pre-AP math. Now in this example, this is actually much more the type of example that I prefer to use because it makes you incorporate more skills. Here we are still same idea. Find the area of the regular polygon. In this case, it's a nonagon, so it has 9 sides. But in this case, if you notice, they're only giving you one dimension. They're only giving you the radius, which is fine. With that radius and the fact that I know how to find the central angle of the triangle, I can use the angle that I get from the uh, radius and the apothem and whatever dimension that they gave me and use trigonometry with right triangles to find everything else that I need to about the figure. So in this case here, the central angle between angle JL and points JL and K, that would be a 40-degree angle. So that means that the angle inside of the right triangle, half of it is only going to be 20 degrees. Now in this case, we want to say, well, what is the lengths of the sides and what is the length of the apothem? So this is where trigonometry is going to come into play. And again, we're kind of just looking at essentially half of that isosceles triangle, the right triangle kind of here. So we're going to be finding the measurements of side MK by saying the sine of 20 is equal to the opposite side over the hypotenuse, so MK over 5. So simplifying for MK, that gives us MK is equal to 5 times the sine of 20, and cosine, or for LM, that's the adjacent side of the angle, that's the apothem. So we're going to say cosine of 20 is equal to LM over 5, so that gives us the apothem to be 5 times cosine of 20. Well, we know the apothem now, 5 cosine 20, but we don't know what the side length is or the perimeter. We know that MK is 5 sine 20, but the entire side has to be double that. So we multiply it by 2, and that gives us 10 sine 20. And because there's 9 of them, that gives us overall 9 sine 20 for the perimeter, or about 30.8 units long. Now here they're giving us that 30.782 number or the approximate value, but it's really not necessary because we're not going to use a rounded number for our calculations. But so now I know the apothem and I know the perimeter. So I'm going to substitute those values into the area formula and say that the area is about 72.314 square units. The exact answer would actually be 225 times sine of 20 times cosine of 20 units squared. That would be the exact answer, but we'll go ahead and round it to 3 decimal places here. Alright guys, it's that time again for you to try practicing the question on your own. So go ahead and pause the video at this point, work out the question, find the perimeter and the area that you're being asked to find. And whenever you're done, go ahead and hit play so you can come back and see my answers and hear my explanation, okay? So go ahead and pause the video and come back when you're ready. Alright, so hopefully we'll see what we have for our answers here. Find the perimeter and area of the equilateral triangle inscribed inside of the polygon. Well, here, 6, FG or FH, however you want to think of it, that is the radius of the polygon. And using the central angle of the equilateral triangle, we can find uh, all the missing sides that we need. I can find the apothem and I can find the length of each side of the equilateral triangle, so I can get the perimeter in the area. So the first thing I'm going to do is I'm going to say 360 divided by 3, so I have a central angle of 120 degrees, and that central angle is going to be divided by the apothem into two 60-degree angles. Well, here I'm really just kind of looking at rules of special right triangles as opposed to the trigonometry that we used in that last example. Now, if you'd use trigonometry, that's perfectly fine. But rules of special right triangles in this case, because it's an equilateral triangle, would probably be a little bit quicker. So the short leg has to be half of the hypotenuse, so that's why the short leg, or the apothem in this case, is 3. And the long leg has to be the short leg times the square root of 3, so the long leg is 3 radical 3. So that means the entire side is 6 radical 3. So 3 of those, 3 times 6 radical 3, gives me the perimeter of 18 radical 3 units, or about 31 units as an approximated decimal number. So now we're going to find the area. So the area is 1/2 times the apothem times the perimeter. So 1/2 times the apothem of 3 and the perimeter of 18 radical 3 gives us 27 radical 3 units squared, or roughly almost 46.8 square units for the area of the triangle. So that's pretty much going to wrap it up for things that we're going to be using for area of a triangle. You have to know what's the apothem. You have to know what the length of the side is. Sometimes you'll be given 2 dimensions in the polygon, so you don't really have to use any trigonometry or anything. You can just maybe use the Pythagorean theorem if you need to find the apothem or the perimeter or the length of the side if you need it. Better questions, more challenging questions, are going to only give you 1 dimension, meaning maybe they'll give you the length of the side, maybe they'll give you the apothem, or maybe they'll give you the radius, and then you either have to use rules of trigonometry or special right triangles in order to find the missing parts that you need in order to be able to find the area of the figure. Now, of course, sometimes they'll give you the area and ask you to find what is the apothem or what is the length of the side, so I can maybe find the perimeter or something like that. But that's essentially going to wrap it up for how we find the areas of regular polygons. If you have any questions about anything that you saw in the video, by all means, get in touch with me and let me know what those questions are. But until next time, ladies and gentlemen, thanks for watching and take care.